Hey everyone, this is ChainGuard, an autonomous supply chain threat investigation agent. It uses a multi-agent AI architecture powered by LangGraph and Splunk MCP to detect, investigate, and remediate software supply chain attacks. On the left, the sidebar shows our agent architecture: detect, flows into investigate, then assess. Underneath, there are three parallel sub-agents: IOC Hunter, Threat Intel, and Blast Radius. Below that, the connection status confirms we are live, Grok LLM connected, Splunk Enterprise connected, and the MCP server streaming. The command center shows a real-time threat level, currently elevated because we have just completed an investigation into a Trojanized VS Code extension. 5 KPI cards track active investigations, critical alerts, total count, pending remediation actions, and MCP calls to Splunk. The recent investigations table shows a completed investigation with its severity score, attack type, and status. Next to it, the MCP observability panel tracks every Splunk query our agents made, latency, success rate, and per 2 stats. At the bottom, the mid-ray attack heat map has lit up with the techniques our investigation detected: supply chain compromise, command and control, credential access, etc. Let's dive into the investigation. A malicious VS Code extension called Code Style Formatter was detected making outbound connections to a CT2 domain installed on 47 developer workstations via Marketplace Auto Update. This is a sample demonstration. This is the investigation workspace. The header shows the investigation ID, the classified attack type, the severity score, and counters for finding IOCs and discovered entities. On the left, the agent state machine shows the completed pipeline: detect, classified the attack, and extracted IOCs. Then the supervisor dispatched 3 parallel sub-agents. This is the multi-agent investigation panel. ChainGuard uses LangGraph Send API to fan out to 3 investigations simultaneously. IOC Hunter searched for indicator matches across all Splunk indexes. Threat Intel correlated with known threats and mapped Mithra attack techniques. And Blast Radius traced how the compromise spread across repos, pipelines, etc. Each agent independently generated SPL queries and executed them against Splunk through MCP. The LLM merge node then synthesized all 3 perspectives, deduplicating a unified narrative. The decision log captured every agent's reasoning. You can scroll through and see each agent's contributions labeled by color. The attack graph visualizes the propagation. Nodes represent compromised identities, the malicious extension, affected endpoint, CI runners. Edges show how the attack spread through the environment. The evidence tab lists each finding with its severity, description, associated IOCs, and Mithra technique IDs. The SPL queries tab shows how every Splunk query generated and executed by the Splunk sub-agents, the actual SPL syntax, which index was targeted, and the raw results. These are real queries run against Splunk by MCP, not simulated. The timeline reconstructs the attack chronology when the extension was installed. On the right, the entity sidebar will show every discovered entity, endpoints, packages, pipelines, secrets, organized by type with severity indicators. It hasn't found any here. At the bottom, ChainGuard generates prioritized remediation actions. Let us click approve and let's say reject this. This keeps the human in the loop and the agent respects my decision. Maybe I want to handle it differently. You have the option to approve all. So this is ChainGuard, a multi-agent AI meets Splunk security data through MCP with humans always in control. Open source and built for Splunk Agentic Ops Hackathon. Thank you.